Hello guys, and welcome to part 5 of my little trees creation generation series. And this time I'm gonna be implementing a different different implementation of the tree generation other than the L system. So basically what I'm gonna do here is to put this L system aside and do something different instead. So before I start to explain what I'm going to do, I want to give out some credits to my main inspiration for this. It came from this stream, Epic Games stream, which Ryan Brucks hosted, or well, he spoke about some of the stuff he did for Paragon. So I watched this video a few times and I picked up a few tricks, I would say, from that, and it's definitely very much inspired by that. So anyway, I don't think I'm going to be doing it the same way as he is doing it, and I'm definitely not going to implement all the crazy stuff that he's doing. So it's going to be kind of a simple version of that, but it should get you started if you're into building this kind of stuff. And anyway, it's a good brain practice, I would say. So with that out of the way, I want to get started by painting out or taking a few notes on what I'm going to be implementing. So if we start off by drawing something, the L system worked by using a kind of a string of characters which would instruct a turtle what to do. And this implementation is going to be different. It's actually going to be a recursive function that keeps calling itself. And what it's going to do is to take a number of branches. So we can start off by typing this out. So, or actually it's not a number of branches, it's going to be segments per branch. Looks like it says branch, but it's branch. So segments per branch. So this number here is going to be a number that says how many, whenever I create a point, how many segments do I want. So in this case, I have 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 segments here. And I want to say when it should branch. So what I'm going to also keep a variable for is something called branch frequency. Like this. So if we set this to, okay, I'm going to say in this example it's 6, in this example let's set it to 2. Then it's going to make a new branch here, and I'm going to be making them on each side every time, so it's easy to see what we're doing. But we also want to decrease the number of segments every time we branch, because otherwise if we keep having 6 branches, segments per branch, then this is going to go on forever. So it's never going to finish. So we're going to keep a variable also called decrease segments per add decrease segments at branch. So let's say we decrease this by 2 also. That means that since we have had 6 to begin with, what it's going to do is it's going to generate 4 branches here. It's going to generate all segments. And here's going to, that's 1, 2, 3, 4. So here's also going to generate 4. But again, it's going to branch every 2 segments. So here, after 1, 2, it's going to generate a new one. 2, and here is also going to generate 1, 2, and here's also going to generate 1 and 2. So with these settings, we should get something looking pretty similar to this. We also want to control the angle of this. So every time we make a branch, we want to say how much do we want this angle to be. And we're going to call this, well, for now, let's just call it angle. And let's set this to 25 degrees. And then if we look at this like it's pointing upwards, like a tree here, then what we can also say is, if we imagine this is kind of like a, yeah, it's pointing upwards. So what we want to do is to also define an angle which we will roll around this axis here. So we're going to keep a roll. Let's set this to this completely random angle, which is the Fibonacci angle. There's some literature explaining something about this. It's got something to do with the way plants prefer to put their branches so they don't shadow each other. So yeah, it's definitely not going to be the same as I'm showing here, but it's more going to be something maybe like this. So this to this. So we also need the same variable as we had before, so we're going to need some segment length, and we're going to set this to 20 centimeters or units or whatever. And we're also going to keep track of the thickness or the width. So let's call this segment, well, I think about the segment width. Let's finish the length first. So we also, it just so happens that usually a tree or something growing is going to have a certain length, and every time it branches, it's going to get progressively shorter. So we're going to keep something called a segment length factor, which we'll set to 0.8 or so. So that means that every time we make a new branch, then we will decrease the segment length of, or basically multiply the 20 by 0.8. And once it branches again, it's going to multiply that by 0.8. So it's going to get shorter and shorter the further out we get. And then we're also going to keep track of the width. So segment width factor. I'm sorry about the handwriting, it's terrible, I know, but it's just the way it is. So I'm going to set this 0.9 or something. So this is going to cause the tree to start at a certain thickness, and it's going to become thinner and thinner. So it's going to create this effect. So this is something that's going to happen. We're going to make it shorter at every segment. But this actually segment length factor, it should maybe be called branch length factor. I think actually that's what I'm going to call it instead. So let me just, God damn it. Okay, never mind. So I'm going to call this branch length factor. I think that's it. That's what I want to implement. So from here on, I'm gonna do the progressions for this, and then in the next video we're gonna start implementing everything. So this video is basically just the theory behind this, what I want to do, and yeah, what kind of features I want to implement. So actually also we're gonna add leaves at some point, and we're also gonna add randomness. So, well, let's keep that for some of the later videos for now. So I'm going to do the initial preparations for this. So let's jump out of painting mode, and I'm going to put this aside. And what I'm going to do here is we have some stuff we made in the last video, last few videos from the L system. I'm going to start off by duplicating the branch thingy here. So I'm going to call this, instead of L system branch, I'm going to call this a tree, just a tree branch actually. And then I'm going to create a completely new blank blueprint based off an actor, and I'm going to call this tree generator. So if we open this up, it's just going to be empty as it is right now. And the L system, if we take a look at what the L system, because we're going to borrow a few things from there. So I just want to keep this, so I have both of them in here. So we have a turtle and we have a spline, so we can create those two things pretty easily. So let's create a spline, and we can create a static mesh. I'll call this the turtle. And then we have all these variables that I just mentioned. I'm gonna put this over here, and I'm gonna bring in a little drawing here. And I'm gonna start adding these variables. So one variable we also definitely need. Sorry about that. I'm just gonna dock this here, and then move this to the side. There we go. Okay, so we're gonna have a tree. That's one thing for sure. And if I just expand this so we can see everything. So this is going to be an array of branches, tree branches. Okay, and then we're going to have this segments per branch, which is going to be an integer. And we're also going to have the branch frequency. Oops. And we're going to have decreased segments at branch. And then we're going to have a few angles. So we're going to have an angle. And we're going to have a roll. You should maybe call this, instead of angle, you should call it yaw. I'm not really sure about this. And the thing is, you can actually add these two as 2D vectors, and then you can decide, have a kind of a randomness built into this also. Which I'm not going to do because I just want to keep this simple, but just wanted to mention that. Okay, and we're going to have the segment length. And we're going to have the branch length factor and the segment width factor. Okay, so let's group up these things, because we want to expose all of this stuff here really, so we can see what we can edit it outside in here. So if I drag out my tree generator, which currently doesn't generate anything at all, then we see we have all these variables here now, but we probably want to get this into a little bit of a nicer structure. So what I'm going to do is to group these things. So the tree is just made visible here to keep track of something like it's just going to be using this for debug. So I'm going to create a category called debug, and I'm going to create a category called branch. I could go crazy with all this and create a branch and a segment and stuff. I like to keep things fairly simple, so I don't have to look around and keep expanding things. Otherwise, I know myself well enough to know that I'm gonna get lost in all these groups. So let's compile that and see how it looks. So now it has this debug section and it has this branch section, so it's a little bit easier to look at. So I also want to finish this video off by adding a few default values. So for example, the segments per branch, I'm going to set this to just a very basic value of 2 and set the branch frequency to every second and set the decrease segments at to, well, 2. I'm going to set this to 6. 4. So this is just default values anyway. So the yaw I'm going to leave at 0 and I'm going to leave the roll at 0. Yes. And the segment length, I'm going to default this to 20. And the branch length factor, I'm going to set this to 0. What did I say? 0.8 and 0.9. So 0.8 and 0.9. Okay, so compile and save. So now I think most of this stuff is kind of prepared. I would prefer to do a little bit more, but I already am at 17 minutes in this video. So in order to break things up in smaller bits, I think I'm gonna leave it. No, let me do one more thing. I'm gonna add one more variable under the debug section. I'm gonna make this an integer, and I'm gonna call this number segment count, and this is gonna be a value that I can read out to see how many segments the settings or whatever I entered here generated. And I'm also gonna add a variable called max segments, which I'm also gonna put in debug section, but I'm not gonna expose this one. So the reason why I want to have this is because if I enter some too high a number or something, then things are gonna start to lag, and kind of want to avoid that. So I'm gonna put in this variable here to keep that in check. Okay, and okay, let's do one more thing then. God damn it. Let's create an initialize tree. Whoops, not here. Initialize tree. That's something I wanted to do since I kind of ended up doing the same thing in the event graph and the construction script. So begin play, and here I want to call initialize tree, and I also want to call that from the construction script. And what the initialized tree is going to have is it's going to keep the logic of everything here. So for example, it's going to keep, we're going to eventually generate a tree. So at some point we're going to get the length of this, get the length, and then we're going to set the segment count to be equal to that, so we can read it out how many segments that we had generated. And we might as well also say, for example, if we end up with a number, segment number passing, count passing the max segments, then we don't want to generate all the spline meshes. So that's not what I wanted. So I'm gonna branch. If this is less than our max segments, then we want to continue and generate things. So this point here, we're gonna put in the generate tree stuff, and over here we're gonna have something with some of the stuff with the rendering. And in case we are above that threshold, then we are gonna like ensure warning. So this is going to be the kind of main structure of this initialized tree. So in the next video I'll start to build all the logic for this. So yeah, stay tuned and see you in the next. Bye bye.